Now let's write this function y equals 7 ln of 6 minus x at the power series. So in class, we learned that if we want to write this function at the power series, we're gonna use one of the non-geometric series sum. So we know that the sum of geometric series is actually equal a over 1 minus r. So it means we need to find a way to write this function as this sum so that we can use the geometric series. So the only way that we can do this for the ln function, we're going to have to take derivative. If the function is something like 1 over x minus 2 squared, something like this, the rational function with the square in the denominator, then you're going to use the integral. So this one for the ln, we're going to use derivative. So we take y prime going to equal to derivative of ln u is u prime over u. So we have 7 is a coefficient, so we keep 7. And then u prime, the derivative of 6 minus x is negative 1. So negative 1 over 6 minus x. So that is our y prime. So if I rewrite this a little bit, we have negative 7 over 6 minus x. This is look pretty similar to the geometric sum. However, we need the first term to be 1. So we're going to divide everything by 6. So that I will have negative 7 over 6 and then 1 minus x over 6. So now clearly I will have my a equal negative 7 over 6 and my r is equal x over 6. Then that means my y prime can be written as n equals 0 to infinity. A is negative 7 over 6 to the and then times x over 6 to the power n. And this series is converged when x over 6 greater than negative 1 and less than 1. So it's x less than 6 and greater than negative 6. So this is the interval of convergence. And then now, however, the problem asking you to write y as a power series, not y prime. So it means the first step, you take derivative. The second step, you will need to take the integral to get back the function. So I'm going to integrating both sides with respect to x. So when I integrate both sides, the left-hand side will ultimately become y because the integral of y prime is y, the reverse. Of course, plus c, but we can move the c to the other side, so we can ignore the c on the left-hand side and then take care the right-hand side. So since the integral of the sum is the sum of the integral, so we're going to have summation of n equals 0 to infinity. And then integral, we have a coefficient, so I can bring the coefficient to the front. Okay, and then we're left with integral of x over 6 to the power n. But integral of x over 6 to the power n, I can write it as x to the power n over 6 to the power n dx. And our integral, the variable is x. So 6 to the power n is just the coefficient. So I can pull it out to the front as well. So instead of writing this, I can write as 1 over 6 to the power n. So this can just same as dx and then 1 over 6 to the power n integral of xn dx. Okay, so they are the same thing. And then I'm going to take the integral of x to the power n dx. So summation of n equals 0 to infinity, negative 7 on the numerator. I have 1/6, one copy of 6 times n copy of 6. So it's going to be 6 to the power n plus 1. And then x to the power n is just x to the power n plus 1 over n plus 1. And of course, we're going to plus c. So now I'm going to remove this. So end up our y function is 7 ln of 6 minus x can be written in this form. So the coefficient, the constant term, we're gonna need to find out what is this. So in class, we have the c is always 0, but when the problem is changing, we need to find out our c. So how do we find c? We simply plus x, put in any value for x between -6 and 6 to find out that constant term. Okay, so since between -6 and 6, the easiest number that we can take is 0. So we're gonna put in 0 into our equation and find out what c is. So 7 ln of 6 minus 0, which is 6. And then I have summation of n. So this step is to find c. And equals 0 to infinity, -7/6, n plus 1, the whole thing is 0, plus c. Okay, so when we put 0 for our x, this whole thing is 0, right? This is 0. So turn out c gonna be 7 ln of 6. So rewrite our final result for the whole thing is 7 ln 6 minus x will be summation of n equals 0 to infinity, -7, 6/6 to the power n plus 1, x to the power n plus 1 over n plus 1, and then plus 7 ln of 6. Okay, so this is the series that represent this function. Now, the question on the practice exam is asking you to find out the coefficient. Okay, so C0, C1, C2, C3, and C4. So to find this, we need to expand this series. Okay, so we can have multiple terms and determine the coefficient of that. So how do we expand that? So 7 ln of 6 minus x will have the expansion. This remain unchanged because this is not inside the summation. So 7 of ln 6 is always there. And then we're going to plus the first term where n equals 0. n equals 0. We have the term will be -7/6 to the power 1 times x to the power 1 over 1. So it's going to be -6, 7/6x. So -7/6x. And then we're going to continue with the next term. So when n equal 1, I just put in 1. And then when n equal 2, I just put in 2. So -7, 6 to the power 3 times x to the power 3 over 3. And then the next one will be -7, 6 to the power 4 times x to the power 4 over 4. And we need C0, C1, C2, C3, C4. So we have C0 right here. This is my C0. So C0 is 7 ln 6. And where's my C1? My C1 is -7/6. And where's my C2? My C2 is right here. So C2 is -7/6 squared times 2. So 72. And C3 is this. So we will have -7/6 times 3, 648. And then the last one will be this thing right here. So we have -7, 6 to the power 4 times 4, which is 5,184. Okay, so that's how you approach this problem.